Hello, and welcome everybody to another episode of Inference Office Hours. Today we're going to be talking about Dynamo Kubernetes, and we have two software engineers from NVIDIA to talk to you about that, Hannah and Julian.
Hello.
Hello.
Some areas where we can be reached if you want to talk to us. You can find us at github.com/AI/Dynamo. You can also reach us at Discord. We have a great conversation going on our NVIDIA Dynamo Discord, so please check us out there. And you can reach us directly at community@nvidia.com. And we're always eager to get feedback, and we would love to hear from you, and we'll respond to you if you do ping that. All right, well, with that said, would love to kick off. And just starting off, we have a bunch of new people in the audience today, Hannah and Julian. So for those people, could you give some context behind what Dynamo is and what problems it helps solve?
Yeah, I can answer that. I can start with providing some context around three key trends that Dynamo is designed to address. So the first one is that LLMs are increasing significantly in size. So deploying them in production now requires distributing workloads across multiple nodes, which introduces complexity in both orchestration and coordination. The second one is that new rack-scale GPU architectures have emerged, unlocking new inference opportunities. So as one example, the NVIDIA GB200 NVL72 can interconnect 72 GPUs within a single NVLink domain, with bandwidth reaching up to 1.8 terabytes per second per GPU. So this level of scale opens the door to entirely new deployment patterns. The third one is that the demand for AI is accelerating across a wide range of use cases, like chatbots, QA, summarization, just to name a few. So each use case has different input and output sequence lengths, and they vary greatly in those ISL, OSL, and compute requirements. This variability makes it increasingly important to have infrastructure that can scale dynamically and that can also allocate resources precisely as needed to meet these changing workloads. So this is why we built Dynamo, to help developers deploy and serve these frontier models efficiently while leveraging these rack scale architectures to their full extent. And
That's
usually, and then to speak on the Kubernetes side of things, normally enterprises use Kubernetes to manage these types of challenges, but Kubernetes wasn't originally built with inference in mind. So that's why we're developing things like the Dynamo Kubernetes operator and like custom resource definitions. Our goal is to make it easier for teams to deploy Dynamo within Kubernetes environments and meet the demands of this production grade inference.
That's really helpful background, Hannah. And before we move on, I just wanted to ask you and Julian really quickly, it's such an exciting platform. What is it that you're most excited about working on this technology?
Well, I think we are at the absolute forefront of technological innovation, right? So we are paving the road. We are pioneering solutions that didn't exist. So that's the most exciting thing about it. Yeah.
I hear that. What about you, Hannah?
Yeah, I'm going to agree with Julian there. So I really love working on like new exciting things, especially problems and questions that don't yet have solutions or answers. And it's really fun to be at a place like NVIDIA where we have the ability to do this with some of the best technology and best engineers available.
Solving the hardest problems, right?
Mm-hmm.
Yeah. Well, something that I've been wondering, and I would love to get some clarity on, can you explain how I'd get started in K8s?
Yeah. So Dynamo, Dynamo, we have a way to get started. So we provide a Helm-based installation flow using artifacts that we published on NGC. So you only need a few commands like Helm fetch and Helm install from our Helm chart, and our operator will take care of the rest. We have a step-by-step installation guide if you're looking for guidance. And the goal here is to make installation lightweight so that you can go from 0 to a running cluster in minutes.
Okay, that's helpful for sure. We actually have our first question from the audience. And again, it's just K8s again. The focus here is where you can find that information. So right here we have the GitHub link for people who want to learn more. Was there anything more that you wanted to speak to regarding K8s? Or do you feel that we got it covered?
I think that like one big part of our K8s setup is our operator. And I think Julian can speak more to what our operator is and how it works.
Exactly. Yeah. So let's take a step back and say and maybe define what's a Kubernetes operator, right? So a Kubernetes operator in general, it's a process that runs into your Kubernetes cluster and which is responsible for reconciling one or several custom resources, right? And a custom resource is a declarative Kubernetes API extension, which allows you to define your own Kubernetes resource type. This custom resource, this extension, is basically the definition of a desired state. So what you want to be deploying, right? And the operator is reconciling these resources and handling the how to deploy and how we can achieve and maintain this desired state. So now applied to Dynamo, the Dynamo operator acts upon our own custom resource, which we call a Dynamo Graph deployment, and which manages the lifecycle of all the Kubernetes resources that are needed to deploy Dynamo automatically at scale in your Kubernetes cluster, right? So it's very easy for users to get started. They just have to create a custom resource, a Dynamo Graph deployment resource, where they define which model they want to deploy, how many instances, and they kubectl apply these resources, and the Dynamo Kubernetes operator will take care of deploying and managing the lifecycle of this deployment for your inference models.
Okay, that makes a lot of sense, and that's helpful context. But how do I scale up and down my deployment?
So
I can do that.
Yeah.
So we have scaling built into Dynamo through a component we call the planner. So before you deploy Dynamo Graph deployments with the planner, there's like a step you have to run called pre-deployment profiling, where you run a Kubernetes job through your Kubernetes namespace, and it measures expected performances at different TP sizes to see where performance peaks. So, and you pass in like ISL, OSL, time to first token, and ITL, SLA targets. And so this is a one-time task per Kubernetes namespace. And then when you deploy Dynamo Graph deployments with Planner, it'll access that data to understand the expected load. And then during the deployment, Dynamo will continuously monitor system metrics like TTFT and ITL. And the Planner component has a lot of cool logic in it, like interpolators and load predictors that'll take those metrics and then perform calculations to determine the optimal number of prefill and decode workers to meet the target SLAs that you've set. And then it uses the operator to dynamically adjust the number of those workers. So it means that you don't have to manually tune configurations as your workloads change. Dynamo will adapt it in real life, like in real time.
Okay, I get that flow now. But what if I wanted to benchmark my deployment?
Yeah, we built benchmarking directly into our workflow because it's really important for inference at scale. So we have a benchmarking guide that shows how to measure, compare, and visualize the performance of your Dynamo deployments along with any HTTP compatible deployed ML service. And what it does is it runs concurrency sweeps and benchmarks latency and throughput with a Python script. So you provide the script with like a model name, input labels, and custom sequence lengths. And you can compare multiple deployments. You can deploy multiple backend types, model sizes, or hardware just by specifying like these labels at endpoints. And the data will be stored in a directory with everything that's collected by GenAI Perf, which is what we were using to collect these benchmarks. And to visualize, you just run a plotting script to generate comparative graphs for all of the test inputs. And everything's managed with Python scripts, and it's easy to customize it by adjusting the concurrency, sequence lengths, or extending the workflow for new metrics.
Okay, great. And so for everyone listening, we've just listed the URL on GitHub for finding that benchmarking guide. So if you check that out and have any questions, ping us, and we're happy to help and provide context. So with that said, would love to take any questions that the audience might have. Please drop them in, and we're happy to answer them. In the meanwhile, just wanted to ask Julian and Hannah, so before you were working on this technology, what were you focused on, and how did that lead to this?
Okay, so previously I was, so I joined NVIDIA 2 years ago, almost 2 years ago, and I started on Nemo, on the Nemo platform, on the Nemo microservices. And then the Dynamo project was kicked off, and then I had the chance to join this adventure. So.
Okay.
Yeah.
And Hannah, what about you?
Yeah, so when I first started, I also started on Nemo first. So I started on the Nemo large language model service. I also did some work on the NGC catalog and for NGC. And then we did some work with the Nemo microservices and NIMS.
Mm-hmm.
And then we shifted to doing like this work on Dynamo and Dynamo deployments.
Okay. And so when you are building out your roadmap, I know that you're planning like multiple steps in advance, right? So how far ahead are you really thinking things through? Do you have a pretty good idea of where you're going to be 6 months from now, or, is it more kind of month by month?
I think we do try to look both short-term and long-term, and we try to keep it pretty flexible. So we have our plans for what we'd like to have in a few months from now, or we have these end goals. And then in the short term, what we do is we break those goals down and we figure out which ones are most immediate. And then we make game plans for those, split up the work among the team, and work towards those, along with any faster feedback we've gotten that we want to address immediately.
Okay. That's helpful for people to know, because there's I'm often actually asked what comes next, right? What's happening down the pipe, and interesting to get some flavor on that. So if you were sitting down with a developer and you wanted to make sure above anything else there were two things you wanted them to know about Dynamo, what would that be? What do you think are the two most important things about Dynamo?
So I think one of the things is that maybe the multi-node and multi-GPUs deployments that Dynamo allows you to do, right? So previously we talked about a very simple use case where you want maybe to deploy a simple model in your cluster. But now it would be interesting to talk about maybe a more complex deployment where users want disaggregated serving, right? Meaning that prefill and decode where are running and scale independently. And also use cases where model weights cannot be handled by a single GPU, right? So in a multi-GPU mode, or even by all the GPUs of a single node, right? So in this case, you need to be able to deploy in a multi-node scenario. And in this case, basically Kubernetes, you are reaching the limits of what Kubernetes exposes. And natively, in Kubernetes, the unit of deployment is the pod, right? but what we want when we deploy in a multi-node setup is that the unit of deployments becomes a group of pods spanning across multiple nodes. And so in this case, in this specific scenario, we want to make sure of two things. The first one is to be able to start all these pods in a all or nothing fashion, right? Which is called the gang scheduling. For example, if we take a concrete example, let's say our workload needs 32 GPUs, right? But only 30 GPUs are available. It would be a total waste of resources, right? If some of our pods would start and allocate the available 30 GPUs, and some pods wouldn't start, right? Our workload would remain in a non-ready state while preempting the GPU resources for nothing. And the second point is that we want the group of pods that are working together, for example, as multi-node deployment for prefill and decode, to be scheduled as close as possible to optimize communication performance between these pods. And that's what we call network topology aware scheduling, and that's the main interest, and that's the main point of using Dynamo operator. It covers all these points and provide the users with all these cool features. So here in the diagram, that's exactly what I talked about, right? So you have a deployment where you have a multi-node prefill and decode in a disaggregated mode, right? And you want all these pods to be scheduled and run at the same time, or nothing, right?
Okay. That visual helps a lot in terms of just providing a unique way to look at what you just explained. I do wonder, again, we were just talking about you're out there really trying to solve the hard problems. And so with that naturally will come big challenges you haven't expected, bottlenecks or roadblocks that just kind of throw everything out of whack for a bit, and then you have to get back to it after you've solved it. What are the biggest one or two challenges you two have both personally faced in this path to create something that hasn't existed before?
Well, I would say it's learning so our operator supports multiple backends, right? TRT-LLM, VLLM, SGLang. It's supposed to be, and it's designed to be extensible, and it's all these new technologies and all these new libraries that are coming up every day almost, right? That you have to learn about and familiarize yourself with. So it's this constant, flow of new technologies and new stuff coming up. Yep.
Okay. Hannah, any thoughts on that? What moment did you? I have a brick wall right behind me, but when did you hit a brick wall in your process and had to work hard to find a solution?
I think one thing that was a challenge for us is figuring out like what in addition to what we can provide, like what do people want and what do people want to use and how do they want to use it? So we've run into a few cases where we'll build something that we think is like really cool, or like we like how it works and we got used to it. And then turns out that people actually want something else, or they want it a little bit in a different way. So we just have to adjust, or like remove some things, add some things, like figure out what is wanted, like what is actually useful in practice versus like what we came up with on you get
used to the intended use case. So you just assume that everyone kind of thinks it through the same way as you do. But again, this is the great thing about being connected to community. So one more time, I want to make sure that we remind the audience here, this is a perfect opportunity to ask Julian and Hannah some questions. And what's helpful to them is when they hear from you, as Hannah just said, it really helps them figure out what you want and need and help optimize this product to your needs. So please reach out to us either now, or if something comes up and you just think, I really want an answer to this a couple hours later, here you can go to our Dynamo Discord, and we'll keep the conversation going there. So as you've been working on these new technologies, you know, the user-friendly nature of it, I know, again, that's always something that you're trying to do, right? But there can certainly be some kind of beginner tips, like to make it as easy as possible to get started. So if you were starting with Dynamo Fresh, what's the one thing you wish you knew? You know, what tip could you give somebody so that they have the best first experience? Like literally opening it up, setting it up for the very first time. Is it, you know, is there any guide you think that they should look at, or, you know, is there some kind of optimization? You know, is there just anything that you think people would really benefit by knowing before they jump in?
I think the link that we shared with the installation guide and yeah, is really the go-to document that people can basically follow to get started quickly. And then also, yeah, the Discord channel is a very easy way to get answers very quickly because users can definitely create some Git issues, right? But it's not as dynamic as asking questions in Discord, right? For us, yeah.
Okay. Well, we did get a question that just came in. Can you give us a little more information about the profiler in Planner? What role does it play when you're setting up Planner?
Yeah, so what Profiler is it's a Kubernetes job wrapped around a script that you deploy in your cluster before you start any Planner deployments. And what that does is it runs your target model with different tensor parallelism configurations, and it measures prefill and decode performance independently. So it then measures like what the optimal TP is for prefill and what the optimal prefill is for decode to meet your target SLAs. And then it also logs how resource use and output latency change as TP sizes and GPU allocations are varied while holding other variables constant. So as a user, you specify ISL, OSL, time to first token SLA, and inter-token latency SLA. And the purpose of this is that when you start deployments with Planner, Planner can accurately scale resources to meet your application's latency and throughput requirements as accurately as possible. And this is meant to be like you only have to do it once. You can always reprofile and rerun it on live clusters to dynamically retune Planner, but it's meant to just be something you can run once, and then Planner will look at that data and make adjustments.
Okay, that's very helpful too. So we just had a question come in here from Trevin on LinkedIn, and he'd like to know, is this technology something you can use to connect and model real-time aviation pathways and alteration for things like land sea driving?
Yeah, I guess whenever you need to be able to deploy inference model, right? You can use our technology to quickly deploy your inference model, and then use this inference model in any kind of domain, right? So if you want to train a model, a specific model for real-time aviation, like in the question, and then deploy this model, then you would use our Dynamo solution. Yeah.
Okay, great. Well, to the audience, we have 1 more minute for any additional questions. Thanks, Trevin, for offering yours. Let's see. All right, 1 more from Trevin. Let's try this. he is asking, with low latency and high communication skills, would this be able to support portable microclusters for transportation efficiency? And the examples he's giving is things like self-driving and medical driving assistance.
Well, it's not supposed to be like a real-time system deployed in a real-time hardware, right? It's supposed to be like hosted in a cloud, right, in Kubernetes clusters. So there might be some use case where assistance emergency would use like an inference model that is hosted in a cloud environment, right, by Dynamo. I mean, using Dynamo. But I'm not sure it's like very real-time focused, right? So yeah.
Okay, great. And it's so helpful to get feedback like this because that gives us a better context for how people are actually hoping to use the technology.
Mm-hmm.
So with that, we have to close out. We've hit our time. But any final thoughts, Julian or Hannah, before we close?
No, I think users, please try Dynamo, provide feedback. That's what we are waiting for, improving our solution and make it great to use. Yeah.
Okay.
Yeah.
And anything else?
To add on to that, if you have any features that you'd like to see and you want to contribute, we are super open and we welcome all contributions to our GitHub repo.
And to the audience that's been listening, thank you for taking the time this afternoon to listen to us. We really enjoy sitting together and talking about this stuff and having you as part of the conversation. If you have any further questions, again, you can reach us on the links that I provided at the top of the show. And otherwise, please join us on our next office hours. Thank you very much.
Thank you.